Hey everyone, and welcome to The Explainer. You know how your analytics powerhouse is amazing for big questions, but you can never really use it for your app's fast, everyday transactions? Well, today, we're diving into a technology that promises to change all that: Snowflake Hybrid Tables.
So let's start with a really fundamental question, one that's basically shaped data architecture for decades. Why do we always use two separate databases? See, traditionally, the system that runs your app and the system that analyzes its data have been totally separate worlds, which means, you guessed it, you're using and paying for at least two different databases.
And here's the reason why. On one side, you've got your transactional workloads. That's OLTP. Think of this like a cashier at a grocery store, needing to look up the price of a single item. They need that one piece of info, and they need it right now. But on the other side, you've got analytical workloads, or OLAP. This is more like the store manager asking, what were our total sales for every single item across the entire country last year? That's a huge query that has to scan millions of records. These two jobs have always required completely different tools, until now.
But what if that old divide is finally starting to close? What if you could build just one system that's great at handling both of those jobs? Well, that's exactly where this unified approach comes into play. And that approach has a name: Snowflake Hybrid Tables. This is Snowflake's big answer to that age-old problem of having to live in two separate database worlds.
So what exactly is a hybrid table? It's a brand new table type right inside Snowflake that's built for these mixed hybrid workloads. And here's the secret sauce, the key difference. It uses row-oriented storage. Now think about it this way. Your typical data warehouse stores data in columns, which is fantastic for those big analytical scans. But if you need to find one specific record, like that one customer's order, it's actually pretty slow. Hybrid tables flip that around and store data in rows, just like a classic application database, which makes those single-row lookups incredibly fast.
And you know, maybe the best part is that getting access to this really powerful new engine isn't buried in some complex setup process. It's literally as straightforward as adding one single word to your standard SQL command: hybrid. That's it. This makes grabbing this new tech and putting it to work just super accessible.
Okay, so it's easy to create, but what can it actually do? Let's get into the technical superpowers that really make these tables tick.
First and foremost, let's talk about speed. We are talking about performance measured in milliseconds for those classic transactional jobs: inserting a new user into a table, updating an inventory count, or deleting a temporary session. This is the kind of blink-and-you'll-miss-it performance you'd expect from a high-end application database, but now it's happening right inside your analytical platform.
Now, that speed is backed by a bunch of features that are frankly non-negotiable for transactional workloads. You get enforced primary and unique keys, which basically means the database itself guarantees you won't get messy duplicate data. You get foreign key integrity, so the relationships between your tables stay clean and valid. And critically, you get row-level lock.
Okay, let's just pause on that last one for a second, because row-level locking is the real game changer here. It's what allows lots of different users or applications to write to the same table at the exact same time without causing chaos. Imagine a big online spreadsheet. Without row-level locking, if one person is editing a single cell, the entire spreadsheet gets locked for everyone else. It's super inefficient. But with row-level locking, only the specific row being edited is locked. Everybody else can keep working. This is absolutely crucial for any app with a lot of users. And all of this leads to a really important outcome. With these features, hybrid tables can support true ACID transactions. Now that's a fancy acronym that stands for atomicity, consistency, isolation, and durability. But in plain English, it just means your data operations are super reliable and your data is kept safe and consistent even when a ton of stuff is happening all at once. Okay, that's the tech. But how does this translate into the real world? Let's look at some practical use cases where this kind of technology really shines. All right, one huge one is storing application state. Just think about all those little bits of data an application needs to just work. Things like user session info, metadata, system configurations. Instead of needing a whole separate database just for that, all that data can now live directly inside Snowflake, right alongside all your big analytical data. Another perfect fit is anything that needs real-time updates. You know, like in e-commerce. A customer adds something to their cart, and that inventory count needs to be updated instantly. Or think about a live leaderboard in a video game. It has to process new scores immediately. Hybrid tables are designed for exactly these kinds of fast, high concurrency jobs. And finally, think about serving data.
So many companies have a whole separate, fast database just to power their internal dashboards or their public APIs. With hybrid tables, you could potentially eliminate that entire serving layer. I mean, you can run your analytics and serve the results from the very same system.
So when you add all of this up, what does it mean for the big picture? Well, the impact really boils down to one word: simplification. You know, this quote from the source material just says it all. Simpler architecture, zero data movement. Not right there is the holy grail. It's all about reducing complexity and getting rid of the need to constantly shuffle your data between a bunch of different systems. This means your app's live, operational data can finally sit in the same place as your historical, analytical data. It just breaks down that wall we've been talking about. And the result? You could potentially get rid of countless complex, fragile, and expensive ETL pipelines. You know, those extract, transform, load processes that do nothing but copy data around. I mean, just think of all the engineering headaches and infrastructure costs you could save. And here's the crucial point. This isn't some theoretical concept for the distant future. Hybrid tables are a core piece of Snowflake's bigger strategy, which they call Unistore, the goal being to unify all data workloads. And most importantly, they are generally available. You can start using them today. And that leaves us with one last, pretty provocative thought. For decades, the constant, painful process of moving data between our operational databases and our analytical warehouses has been a core challenge in data engineering. With technologies like hybrid tables, could we finally be seeing the beginning of the end for that entire era? It's a powerful question.